All right. As you can see, as Evelyn said this morning, if this were easy, it would have been done. And I'm really impressed to sort of see how we're doing. So now we've talked about the what, we've talked about the why, we've talked about the how, and now there's the group that I sometimes flippantly refer to as the screw it, we'll do it live. Which it came out of our first meeting a year ago, where there was some frustration of people saying it can't be done, you can't do this. And so I'm really happy that led by Jennings Askey and Jim Jacobson, they decided, hey, let's show that we can do this for our own little corner of the ecosystem, and not as a pilot, not as a commitment, but as a let's just demonstrate that we can do this as a proof of concept. And Melinda, I'm going to ask you to open Jennings Askey's line, who's going to join this presentation. And let me run over here and pull up your slides. I'm just going to go over here. Give me one moment. Oh, that gave me that warning earlier. All right. Thank you, Jim. And we've got Mike from New York Presbyterian as well to join this presentation.
All right, so you'll hear from me, Jim Jacobson, as well as Mike Didymo from NYP. So the goal here is to give a status update of where we are, and where we are is basically the report that you saw the handout out. You saw outside as a handout, and you hopefully have in your hands now or on your computer now. But the status of that document is that it is content complete, format complete. It's available now for feedback and for final feedback based upon everyone's input. So if you have input, please send it to the mailing list. I would ask that it be 2 weeks minus a day, because we meet on Thursdays and we want to be able to sum it all up by next Thursday, by two weeks from now on Thursday.
Yeah.
So it's based upon the feedback today and subsequent feedback. So where did we start? We started with establishing our goal of a collaborative effort between manufacturers and healthcare providers to find a format that would work for us to communicate this information from one side to the other, and show by facts on the ground that we could communicate the information, and more importantly, that we could effectively exercise use cases against that information to show the utility of it. So the result is that we did prove the effectiveness of SBOMs as a tool for transferring this information. That this information was useful, and it was information that has never been available to healthcare delivery organizations up until now. So it's a concept that works. We have a lot of bumps in the road in going through this proof of concept, because there was a lot when we started out that was not determined. But we took note of those technical issues, and we'll provide that information in the findings in the report. I mean, we have provided that information in the findings of the report. So last time we were here, we talked about the fact that we had some observations, but we had not collected it all into specific findings. Today, we present the full findings of the proof of concept. And just a reminder of what we did include and what we didn't include. We used SWID and SPDX, both formats. In almost all cases, manufacturers produced those in both formats. We tried to tackle the the topic of dependencies. You'll see in a little bit that that wasn't entirely successful, but we did take it within scope. We wanted to deliver this content over the internet and in a machine-readable format. We excluded hardware. At the time, the FDA was concentrating on SBOM, which a cybersecurity bill of materials, which included the concept of hardware, but we did not feel that it would enhance the ability of the proof of concept to show effectiveness. We did not include vulnerability information, although that was one of the topics that we considered. We didn't feel that that was the right level to identify vulnerabilities. Unique identifiers, we didn't want to tackle the naming issue, so we came up with a provisional way of dealing with that. And we didn't provide significantly the idea of, yes, this component's in here, but you don't have to worry about it because Z. And we didn't include an API to access the data. So these are the number of use cases that we did explore. Initially, before we started the proof of concept, we said, what are the use cases for the proof of concept, but also what are the use cases for using SBOMs for medical devices in general? And in consultation with the other, with the use case group, we identified 7 use cases for procurement. And for asset management, we broke that down into 3 categories: general asset management, risk management, and vulnerability management. And I'm not going to go through those numbers, but you can. This is an example or a summary of the use cases that we will be talking about today, the findings that came out of the exercise of the proof of concept. So with that, let's skip right to the findings, because that's the meat of what this report is all about. There's some overview in the report, some description of the use cases, but the real meat is the findings. And so that's what we really want to talk about today. So first of all, these are not, we don't start off with the findings against the specific use cases, because we also wanted to examine how easy or difficult it was to generate SBOMs and to ingest SBOMs on the other side. So we looked at generation first, and we identified the fact that there was no automated process that existed today. No tooling provided an end-to-end chain of generating an SBOM. So in many cases, there was some automation involved and some scripting involved, and also manual process involved in generating a relatively small set of SBOMs. The flexibility of SWID and SPDX, we said, was great, but with flexibility, you get ambiguity. And so what we had to do was create a specific interpretation of how we would use SWID and SPDX, both in order to convey the information that we needed to. There's a lack of standardization for certain of the elements that we were communicating, component ID being principal among those. And I don't need to reiterate that. That's a well understood problem for everybody. In order to get to the level of full automation, it would require being able to pull information from many different sources within the supplier's environment. So in the case of medical devices, the information is represented often in many different sites, or many different elements of the manufacturer's operations, different business units, different ways of representing the data. And so that was a challenge noted that we would have to overcome for full automation. Dependency information was also challenging. And just opening the kimono, there was some doubt amongst manufacturers about could this information actually be useful to the healthcare delivery organizations. And I would say we were unsuccessful in exercising this aspect of SBOMs because of the complexity of producing the information. It was a challenge that eventually we felt was not germane to proving that you could use this data rather than showing the complete tree at any point, because that was a challenge that we couldn't meet because of the reasons that we've all identified of creating a complete tree. Josh?
Without completely stopping the flow, I want to come back to this because, as I said, we can claim it's difficult. No one asked me, like not one of the participants. It's not an indictment. It's just I could have produced some. It would have had more things in it. Some of those are exploitable things that a hospital, if they saw that, would say, oh, I remember that attack. Yeah, that could have affected me. I would have liked that heads up. So I hope it's not self-fulfilling.
Right.
And I respect that phase one was very tightly scoped. But my bigger point is I hope it's not self-fulfilling. It's too hard, because had I been asked, I would have provided.
Yeah, so we originally included it in scope, but felt that in order to get to that level, it wouldn't provide enough data about usefulness of SBOM information.
Yeah, and I disagree with that, but I'd like to make the case offline. Yeah.
That's a perfectly legitimate position, but we were just trying to exercise the use cases, and none of the use cases depended upon that information being available. So it's maybe something that we work on in the future. Okay. The device ID we've talked about, component ID we talked about, but the device ID, that is the end product or that is being delivered to the HDO, there was no way to specify that within the SBOM. So that was communicated external to the SBOM. So, that there was an external file, like a README, basically, which mapped that out. And maintaining SBOMs per software version was identified as not something that was encountered during the proof of concept, because we limited the time frame for the proof of concept, so there wasn't a lot of change over time. But the aspect of maintaining multiple versions for an installed base where you could have hundreds of products with dozens of versions, tens of versions, 5 versions, whatever it is, that becomes an increasingly large headache, or potentially could be, depending upon the infrastructure of the manufacturer, how many different versions they maintain in the field, et cetera. Because these systems are not necessarily always updated. We often include or make available updates, but often they're not incorporated by the end user. And so now we'll talk about consumption.
I had one comment here because it came up recently. Many times, the product developers don't actually know what version of a component goes in, because the creation of these picks the latest one at the time. And so if you create your software 10 minutes later, you might get something different. And the tools available in many cases don't keep track of what version actually came in. They just pick the latest. And that is something that needs to be considered, in tooling or something like that. I know that One company, which most people have heard of, Netflix, has changed their tooling in order to, because none of the standard tools gave that information for them, but they're doing that today. And so this is an issue for versions, which you were just talking about, and the fact that people may not actually know what version is in there.
One comment there. Oh, go ahead.
Just a response to that particular point. That just grabbing the latest version, not having a lock file, is identified as bad practice. And there actually are CI/CD pipeline tools, including ours, and I'm sure lots of others, that will flag non-specified versions of dependencies as a fail state and break the build. So we have commercial products in the marketplace that will actually preclude software building if that specific state exists. So if you have non-version dependencies and it's in a bill of materials, it's pretty, you can see where it's not specified because there isn't a version specified because it's picking up the latest. That is in fact explicitly expressed in the software bill of materials with a non-provision of version. And you can flag that as a high-risk software bill of materials.
All right, so next we're going to take a look at the consumption or the ingestion of the bills of material, as well as the real findings from the use cases, the important stuff. And for that, I'm not going to speak to the important stuff. I'm going to leave that to Mike.
Thank you, Jim. So to reiterate, the HDO's consumption analysis and ultimately the exercise of these use cases was successful, but certainly not without some challenges and areas for improvement. So I'll go through some of those. The first one, and perfect segue from the previous presentation, was the lack of a standard universal ID for those particular components. Without that, there was some manual intervention required, some human element to actually go into the SBOMs and make a determination as to what those particular components were. The HDOs did try to leverage some approximate searching or fuzzy logic to see if it would yield reasonable results based on that, but ultimately it was determined that the doing so would not represent accurately exactly what those components were, so we highlighted it as one of the primary challenges. And a lot of the other challenges that we do have do kind of dovetail a bit off of that one or overlap a bit. The second one, which certainly does, is that some manual correlation was necessary with and without some varying success. So in situations where it was pretty easily identifiable as to what that component was, but didn't necessarily match across multiple SBOMs, we could say, well, it's either this or this, and then map that to a particular item that we were using from the National Vulnerability Database, and then create a risk profile for that particular attribute. There were other situations as well where we weren't necessarily sure exactly what it was and had to maybe make an approximate guess or some type of assumption as to what that may be, and then assign a risk rating to that as well. The third one is that there was no authoritative end-of-life software database to automatically pull from. Whereas we used the National Vulnerability Database and a feed from that to create something to kind of throw these attributes at and then return a result, there was nothing that had authoritative end-of-life dates or data that we could potentially pull from. So we had to do that somewhat manually. The next one is custom software. So it wasn't reasonable to make the assumption that just because something wasn't found or couldn't be identified, that it could be custom software that was included as an attribute within the SBOM. As such, there was really no way, no flag or no particular item to say this is software that was custom developed and has been included as a software dependency in this SBOM. And as such, there was no way to correlate that to the overall risk profile of the device, just due to its unavailability. Another one was the lack of a patch level. So some of the more hefty or bulky components that would change drastically, the vulnerability and exploitability would change drastically depending upon patch level, had to be assessed manually. So there was no way to see, for instance, with the Windows OS, what KBs and patches were installed upon delivery. That had to be done separately and then maintained separately as well. And lastly, on these, overall, the completeness was essentially accepted as is. There was no audit or validation done by the healthcare delivery organizations. So we had to have a reasonable level of trust between us and the MDMs to say this is not only accurate, but also complete. We didn't do any type of gap analysis or actually take that and then look at the device and see if we could enumerate other things that were not particularly defined in the SBOM. So some particular use cases, the procurement use case. Across the HDOs, we did not have anything that could automatically import this into procurement tools that we were using. Unanimously, we did use a SIM to do that and write some custom scripts to get the data into there and then really use that as the data warehouse, so to say, or source of truth. As I said, compare that against something like the NVD and then use that really as the central point, and any of the other systems would be calling upon that to identify those particular things. Another one was the lack of a schema definition, an XSD. All of the HDOs essentially came to the same conclusion as to how to parse it out, just based on the SWIT or SPDX files that they got. But there was no actual definition file to just say, here's how you should do it. One of the things in the use cases were that, on the success side, were that device vulnerabilities could actually be quickly identified. Assuming all of the challenges are addressed and we have an accurate and immutable name such as CPE or something like that, assuming you can get that in, you can go to something trusted as the National Vulnerability Database. You could easily make that correlation and generate a risk profile for that device, both upon delivery and installation and over time as well. Subsequently to that, you could also, if vulnerabilities are identified as part of procurement, look to necessary compensating controls to mitigate the vulnerability or exploitability of that. If you know there's a known vulnerability that's on a device and it's being introduced into your environment, you could look at something like network isolation or access control lists and firewalls to bring that in, but then mitigate that risk. And then lastly here, we do have one that says HDOs were unable to correlate SBOM data with component end of life due to lack of readily available end of life information. How to be done manually. Second one is asset management. So the current implementation of the CMDBs and CMMS systems across the HDOs were unable in their current state to import or map the parsed SBOM data. It's not to say it wouldn't be possible with some tooling or custom scripting. In fact, we New York Presbyterian have worked with our vendor ServiceNow and kind of said, hey, this is something we'd like to actually explore, and their eyes started to open up wide. And it's certainly something that they said could be implemented so that the asset inventory could have this information available there as well. As I said, customization or additional tooling could be done. Due to the timeline and scope of the proof of concept, it wasn't done, but in concept, it would be successful. And then, as I mentioned, after the POC execution, there were some vendors that did express interest in moving forward with this, and we have had additional discussions around that to get that spun up. Risk management use case, we didn't consume the SBOMs directly into any risk management or EGRC tools. Conceptually, though, it could be done as well as it is all machine readable. Similarly, the ongoing monitoring of devices wasn't done just due to the truncated timeline, or short timeline, not necessarily truncated, but short timeline of the POC, but it's certainly feasible. There's nothing to say why that wouldn't be feasible to do going forward. We were able to use the CVSS scores in the NVD to come up with qualitative data. Now, I think it's certainly been mentioned here in the past, vulnerability, exploitability, different things. So that qualitative number is certainly something that needs to be analyzed a bit further. In addition, even though some libraries may be exploitable, it could even go down to the method or function level that is actually being called or used. So it does kind of provide that surface profile or risk score, so to say, but additional analysis is likely needed. As with all the other use cases, kind of common thread here, lack of a naming convention certainly impeded the execution, full execution of this use case. And we did identify as configuration vulnerabilities as a gap. There's no real way to represent configuration vulnerabilities. So you can look just at the components and say, yes, no, but it may be contingent upon the specific configuration of that component that actually results in the exploitability or not. And lastly here is vulnerability management. So the findings were essentially consistent with other use cases. I don't need to go in those to those much more detail. Some things that were interesting were kind of the opportunity or potential for red and blue teaming exercises, sort of some unique attack vectors. So to do some more focused and red-blue team exercises within the healthcare delivery organizations that use unique attack vectors that we may not see all the time. And then subsequently, develop defense plans against those, something we're necessarily maybe not placing as much focus on. The SBOM, when presented to our vulnerability management teams, did not have an immediate or material impact on the way that their current practices were being performed. However, they did say that the risk profiles that were generated upon assessment of the SBOM could be paired alongside some vulnerability scanning results to create a more holistic view of that device. Okay. And with that, I don't know if Jennings is on the phone.
I am. Can you hear me?
We
Yep.
can.
And can you see the slides?
I can.
Wonderful.
Yep. Well, the slides are actually, the video is lagging a bit, so I'm probably just going to wing it a little bit. First, I want to apologize for not being able to make it down. I had a little issue with the day job and had to head back to the hospital, so I apologize I'm not there. I think just in terms of conclusion and next steps, a couple things stand out for me. First, I just want to begin by saying, and this is not in our conclusion, but I agree with Josh that the dependencies are needed and would provide further insight. And I think it's a discussion we have to have and try to figure out how do we get from where we are to where we need to be. And this speaks to really the goal of this effort, which was, let's just get this done. Let's make this up on the fly, if you will, a little bit, because there were discussions in healthcare about this for some time. There were groups in healthcare proposing healthcare-specific SBOM formats, which was kind of loathsome. And so we wanted to basically contribute to the broader discussion within our industry vertical, but also be part of the cross-industry discussion that occurred. So I think, in terms of just thinking about the ultimate findings of this, it's clear that SBOMs can be generated and consumed as it relates to medical devices, and this is something that is viable. And ultimately, the FDA's proposed final guidance that would require this, I think that's a great step in the right direction, and we have to talk about how as an industry we would implement that. But the idea that this can't be consumed and doesn't provide value is, I think, something we should just take off the table right now. We had transparency we have not had before, and in terms of operations, I think we successfully realized many of the use cases, maybe not to their fullest potential, but those are things that we can tackle down the road. The other thing that really stood out was that as we talked about this, I'm speaking to the New York Presbyterian experience, with some of our key information security and technology partners, there was a real interest in this outside of just the people working in the POC. And this speaks to really, I think, the next steps conversation. At the end of this, I think everyone who joined those Thursday calls realized we need to do a second POC. We need to think about the lessons that were learned, incorporate those. We need to think and discuss this with the other working groups and think about what the requirements for this second POC would be. And I think a key finding was we really need to think about the ecosystem of partners that would be necessary to make this real, and this speaks to the issues around automation and tooling on the MDM side. The discussion we've had all morning about just different aspects of the challenges with the current standards and opportunities that exist. And then on the healthcare delivery organization side, as Michael was saying, we have CMDB and CMS vendors that are ready to step up and help with the ingestion and thinking about this as a feature for their customers in the healthcare space and obviously outside of that. I mean, ServiceNow is not specific to healthcare, right? And so they're intrigued with the idea that they could be the repository for any industry, customer from any industry vertical that leverages this. And I think that's one of the exciting aspects of this second POC that we've just kind of had high-level conversations, right? It's expanding this to more MDMs, more HDOs, and also ultimately involving other folks who are in this meeting and some of the other stakeholders, and then folks like Splunk and InfoSec companies as an example. So there's nothing written in stone, nothing concrete, but I think we need to line up this POC and start thinking about how do we expand this. And one thing that was even thrown on the table was expanding it outside of healthcare and having maybe another industry vertical or two joining and really trying to push the envelope on this and making it practical. So I think just to wrap up my comments, I couldn't be happier with the participation, the collaboration, the fact that we showed that the goal of software transparency is not some fiction. It's something that's very doable. It doesn't mean that it's going to be easy to really operationalize this in a sustainable manner, and those are the sorts of challenges we need to think about next.
Thank you, James. Any questions? Got just a few minutes before our scheduled break. Yeah.
Hi, this is Duncan. So 3 points. Number one dwarfs the other two by far. So thank you very much to both the hospitals and the medical device manufacturers who did this. This was a really lot of work. It made some very valuable findings. I'm going to nitpick on a couple things, and I'm sure other people will too, but the bigger picture is this was really good. I realized you had to go through a lot of policy issues. You had to go through a lot of legal issues that are just not fun to do, and it was just, you should be applauded for the work. Now, to nitpick a couple things. Josh had mentioned the point that, you know, as a supplier, he didn't supply it, and you said, no, that was in your terms of reference. You guys decided to only go one level deep. That doesn't actually show up in your SWOT analysis, and so your slide sort of showed a couple points that don't show up in your SWOT, and I just wondered if it could possibly be added or added to what you want to do next or something, but just it seems like verbally more came across and comes across in the paper. That's one point.
Can I speak to each of the points separately? Otherwise, I'll forget.
Okay, sure.
So the question of dependencies has come up, and what we tried to do is make this as realistic and real life as possible. And so when we're reporting findings that the NDMs were being grumpy about dependencies, that's what's going to happen in the real world. And so what we have to do is prepare ourselves, prepare the arguments so to speak directly to these people that are wondering whether or not it has utility.
Yeah, if I could comment too, I think one thing to keep in mind is that we really had a primary goal of showing this can be practical and real. And there's going to be lots of nitpicky things. We talked about that every Thursday. And we, first of all, really appreciate the nitpicky feedback because we want to incorporate that where it makes sense into the final document. But this is the thing that, you know, all good things in life happen through iteration, whether you're developing a recipe, technical standard, or a business process. And so our goal was to get this over the hump, so to speak, and tee up the questions for the next one, which I think is really where we are. So feel free to nitpick. I think we welcome that feedback and the dialogue as we move forward.
Thanks. And then my third point was, and I'm not sure if it's to you guys or more to one of the other working groups, and that's you mentioned the patch levels weren't available, which gets into the whole discussion of is version a version or is version the version and patch is something more detailed. And so I'm not, I guess it's more a question of the framing group and or the, I guess it'd be the framing group as to what defines version, or maybe that's a this afternoon discussion, but it seems like that fact meant you didn't actually have the version, well, at least I think of as the version, if you didn't have that the patch was in or not. So I don't know how to address that question because it sort of crosses three areas, but I do think that's an important finding because it matters, that we somehow have to address. Thanks.
I think that's a great point. I think we can tie that back to the naming issue that I think we're going to talk briefly about after lunch. And just in the interest of time, I see that Josh has a hand up. Oh.
Just that you're getting a lot of nodding heads.
Yeah.
Okay.
So just, there's a lot of onlookers and recordings and notes being taken. So just to overtly express, I have good, respectful relationships with managed device makers. I'm not beating them up. I'm merely saying, for this system to work with that graphic we show, with that big sideways tree, upside down tree, right side up tree, whatever you want to pick, for this to work, a basic primary assumption is for a final goods assembler to meet the requirements of its procurer or regulator, they can't do it unless they also put pressure upstream. And I'm trying to, with empathy and understanding the scope of this, and I think Jennings and I are converging on this, it is useful, necessary, and valuable to start putting pressure on your upstream suppliers. And I was remarking not to beat anyone up, but if I haven't been asked, no one can claim they couldn't get it, right? So that I'm choosing to believe that I wasn't asked because of the scope of phase one. Not that it's impossible to get, but that we chose not to ask yet. I would hate some of the critics of the SBOM process watching to conclude, see, you'll never get it. And I want to be really, really careful in our language that we didn't ask for it, so therefore we didn't have it and we don't yet know the value is a different statement than we should start to ask for it so that my upstream suppliers can be good suppliers to me.
Right. And I think device manufacturers in general have criteria for their providers, their component suppliers. And it's important that this be one aspect of that. I would say it's probably very rare today.
And moreover, if I don't give it to you, I should lose your business, right?
Right.
So it's a great segue to flag what we want to do next, but just very quickly, any last questions, comments? Again, 2 weeks minus a day to get to, and this is, again, I want to echo this comment that this is an incredibly solid effort. We've heard from a lot of folks that it's one thing to talk about something, but to actually build something, that's impressive. So thank you all. Great job to everyone involved in that.